Hi everyone, my name is Kingsley and welcome to another section of this series on the ASA. If you've not been following the video, you can check out my YouTube channel. We've done some implementation with regards to the ASA. I think we started with the active standby failover or high redundancy for the ASA, as you can see from topology on the London DC. And then we started building VPN tunnels from the remote sites. And then we looked at different scenarios, especially when you have one of those scenarios is when you have overlapping IPs between two sites. So in this case, London DC and New York DC. In this section, what we want to look at is a different scenario entirely. So now, if you look at this topology, we have the London DC, we have the maybe Frankfurt DC, or you call it France DC, I don't know, depends on what you want to call it. We have the New York City DC. These are three different sites. Now, we've been given a task, right, to ensure that the application running on this server can talk to the application running on this server, right? As well as the servers in London DC. Okay? Likewise, this server should be able to talk to every other servers in both internally and the remote sites. Of course, here we don't have any other server, right? Now, it's very easy as a design engineer. We can simply build a tunnel between these two sites, right? We can simply spin up another tunnel, site-to-site VPN between these two ASA, and then traffic to this server simply hits this ASA, and then it's tunnel across to the Frankfurt data center. But the requirement says the traffic must route through the London DC. It could be for any reason. I mean, this is like a hub and spoke topology, so it could really be any reason. Maybe here we have some, resources and security devices. We want to have visibility into traffic that goes between two spokes, right? So I've seen this a lot in companies where there's a requirement for all traffic to route through a particular location, like in this case, the hub, right? And so, yes, so that's the task, right? So we need to figure out a way of making sure that this server can reach this server and going through the hub. Of course, there are different solutions to achieve this task, right? Let's say we are not even running ASA. That's where you have maybe the MVPN. You can also spin up the MVPNs and then, route the traffic through the hub, right? And the MVPN is even a better implementation, right, compared to what we have now. But this is what we have. What we have is ASA. ASA doesn't support virtual tunneling interfaces, not that I'm aware of, but I know like the Cisco Firepower, of course, support that. And yeah, so what we need to do is we need to build static site-to-site VPN between the two spoke, between the Frank DC, New York DC to the London DC. And then we need to figure out a way to tell this ASA that if traffic comes from the New York DC and the destination is Frankfurt DC, right? Then just route it back on your outside interface to the server, right? Now the solution to this type of implementation is something we call Hairpining, right, on the ASA. And so we need to implement Hairpining on the ASA. And on the remote site, we are not really doing anything fancy other than just, taking the subnet, tying it to the access list here, and taking the subnet as well, tying it here. But here, we need to do a little tweaking on the NAT, right? And for the traffic to be able to hit this ASA and then route back on the same outside interface to the Frankfurt data center. Now, we don't want to spend too much time explaining. The best way to understand is to lab it up, right? We are going to demo this and then we are going to see what we need to do. Now on this topology, I've already gone ahead to do something, put some things in place just to make the time so that the video does not become too long. Right now we have site-to-site running between this site already. So there's a site-to-site from New York to London DC. There's already a site-to-site from Frankfurt to the London DC, right? And so these servers already have reachability to these servers. And of course, these servers already have the Frankfurt DC server, which is FRA server, already have reachability to the London DC server. What we don't currently have is communication between these two servers, right? So that's where we are. This is our topology that we'll be using in the video, and yeah, so everything is already fired up, and what we just need to do is console to the ASAs. So this is the primary for, okay, so this is the ASA in London, right? So yeah, so it's the primary and active. This is the Frankfurt ASA, and also this is the New York City ASA. All right, so so we just need to pick one server from each location. So let's pick the London DC server, the FRAC server, and the New York DC server, right? So what we just need to do is test connectivity, right, between the spokes and the hub. So I've already given, I think I already gave an IP to this server. So this is the IP 252. So let's go back to the topology. And so as you can see, his IP is this is the New York City. Okay, so the IP is 10.10.252, which is what you have here, and this IP is 10.0.0.20. Now you know we are doing, if you've been following through the video, you know we did overlapping IPs, right? We do have overlapping IPs, and so we are doing something related to identity NAT, right? So the actual IP of this server in this case is going to be what, because this location, the dummy IP that we chose was 192.168.10.250 10.0/24. I mean, okay. I think I might just need to add it there. So if I should ping 192.168.10.20, we should have reachability, right? So this IP actually mapped to 10.0.0.0. If you want to understand what I'm saying, I think you should just watch the previous videos. It's clearer there, so that we don't waste too much time trying to. But what I was trying to explain here is that on the New York DC, if I do show run NATs, so you can see we're saying if it's coming from this subnet, it should be NATed to 20.0, and the remote end is 10.0. So this is identity NAT, which is what we have implemented here because of the overlapping IPs. Okay, dokie, and same for this server. So let's go to the FRAC server, which is this, and then let's also check our IP. So the IP is 172.16.10.252. So here we are pretty clear because there's no overlap here, so we can just ping the same server, but this time on the actual IP, which is 10.0.0.20. So we have reachability. How do you know if you have reachability? You can check the show crypto. I'm running IGV2 here. We've also gone through implementation of IGV2. If you don't watch the video, you can go back and watch it. So as you can see, there's a child security association. If I do show crypto IPsec SA, you can see yes, traffic. There's actually encryption and decryption of packets. So source, this is the local subnet, and of course this is the remote subnet. Okay, and then you have your SPIs, and same for the New York DC. Show crypto ICAM SA. I'm not sure what we are running here, so it's also IKE v2. So we have IKE v2 and IKE v1. I know we did all them. We tested how you can migrate. So you can also go check that video out on my channel. Show crypto IPsec SA. So similarly, you can see. So everything is okay here, right? Between spokes. So now let's implement the tags we are given, and the tags say we need to allow traffic from this server to this server. Now if we try it, let's see. So I'm going to say here on this is the New York City firewall, so we need to go to the Frankfurt firewall. I'm going to start the ping. I'm going to say I want to talk to 10.10.252. So ping to 10.10.0.10.252. Not reachable, right? It's not reachable. Now there are two reasons why it's not reachable. We're going to talk about that. We can also do the same from New York City server, right? So ping to 172.16.10.252. It's also not reachable, right? So there's no reachability between the servers, right? But if we go to the London DC, which is London DC server, so can I talk to 10.10.0.52? Now remember, we are doing there's overlap, there's a domain IP, and that IP is going to be 192.168. So in this case it's going to be 20.252. So you can see there's reachability, right, when I point to the NATed IP. And on the Frag DC, the IP is going to be 172.16.10. I think it's 252 as well. 252. No. 252. Yes. So these servers can. Yeah. So this server can talk to this server and the Frankfurt server, but the taxes. Let's fix this communication here. Now, so the first thing we need to do is we need to look at the access list here on these two ASA. All right. We need to include this access list. We need to include the subnet. So on the New York City DC, we're going to say if traffic is going from this subnet to this subnet, please take it through the tunnel. Right? That's first. So we will do the same thing here, that if the traffic is coming from this subnet and the destination is this subnet, what do we want to do? Just route it through the tunnel, right? So we'll do that. Same for on this ASA, we're going to create an access list to say if the source is this and the destination is this, route it back out through the tunnel. That's actually the U-tunnel. So let's fix this to ASA first. So I'm just going to come here now on the Frag DC firewall. This is our Frag DC firewall. So if I come and say show run access list, so we have an access list that is called our VPN ACL. If you do show run, crypto map, so you see we're actually matching this access list here, right? So this is the crypto map for the tunnel, right? Of course, there's also the show run tunnel group. So you can see the tunnel group, right? Which 192.168.1.30 is the IP for the London DC. So what we need to do now is to just add to the access list, right? And I like using objects, route objects, not route object, but objects. Show run objects, that is network object, or I think GDPR calls it address book. So so I already have the network object for the New York DC. Now there's something I need to explain here. Remember, when the traffic leaves this network and is coming to London DC, the subnet is NATed, right? So what that simply means is that the London DC and the Frank DC are not aware of this subnet because there's already an overlap here, right? So whenever we are referencing the New York City DC, we can't point directly to this IP. I think it's very clear because, come to think of it, if the traffic leaves the Frank DC and it comes to the London DC, the router is going to look at its routing table and it's going to say, oh, it's part of what? That's /16. So it's going to forward it inbound, right? So whether we are on this London DC or on the Frank DC, we can't point directly to this IP. Rather, we want to point to the NATed IP, which in this case is 192.168. I think I should just include the description here. 192.168.20.0/24, right? Is NATed to 10.0.10.0/24. I initially had it in the previous video, but I took it out. So since we still need to reference it, I think it's best we add it here. So duplicate. So this is the NAT statement here, and also here we are doing it to so what we did here was that we carved out a slash 192.168.10.0/24, and so we are natting that to 10.0.0/24. Okay, so this is the current NAT statement. All right, so, I mean, if you've been following the previous videos, you know we originally had this there. So like I was saying, when the traffic leaves this network and comes to the London DC, we want to be sure there's no conflict. We want to be sure the firewall doesn't send it to the internal network. Rather, we want it to NAT it to forward it back to the New York City DC, right? So what that means is, since this IP gets translated to this IP, this subnet, right? So in London DC, what we now need to reference is, we still have to reference this IP, right? So it means in Frank DC, whenever we are referencing the New York City DC, this is the IP that we know. We don't know about this IP, right? So the access list we are creating here will match this subnet and not the actual internal IP that is being used. That's the point I'm trying to make here. So I already have a network object for that subnet, which is 192.20. So what we just do is, so I'm just going to say show run NATs, and let's try to expand this a bit. So I'm just going to copy this. Yeah, so everything here still remains the same. The only thing we are changing is the destination, right? So the destination in this case is going to be this object network, right? So we're saying don't translate. We can say no proxy and do route lookup, right? So show run NATs. Yeah, so I think with this we are good. So we're saying if it's coming from this network, right? If it's coming from this subnet, NAT it to this subnet. It means it literally means unchanged. And if it's coming from this and the destination, don't also NAT the destination. Okay, in 100% of the cases that I've implemented, the destination IPs is always still the same. This is what we call NAT exempt actually, right? So we've added the NAT rule. We also need to add the access list, right? Show run access list. Yeah, so we also need to also match it on the access list. So we're saying if it's coming from match, if it's coming from this local network, and it's also going to the subnet. Okay, so show run access list. Yeah, so I think with this we are good on the frag DC. So if it's coming from this network going to the NATed pool or the NATed subnet. So we need to do the same thing. So we're basically repeating the same thing on the New York DC. So here, show run access list. So we have an access list that say if it's coming from this subnet. So if it's so you see we are not even referencing the local subnet even on the ASA, because if you look at the hierarchy or the hierarchy at which if you do a packet tracer, I don't know whether to show that here, but you know NAT rule always come in first before the access list, right? So NAT rule are matched first before you start looking at routing table or even every other things that need to be checked. So that's why as at the time the access list is matched, the IP would have already been NATed. We've already discussed this in the previous video. So now we just need to just add to this access list, right? So in this case, I'm just going to say now the destination is no longer London DC. We are saying if the destination is my bad, we need to, let me get the route objects, show run objects. So if you're following through with this video, if you don't have the object, you can create it or just reference the IP directly. So the object group for Frankfurt DC, this is the object group which is already on this ASA, right? So I'm just going to reference it here now. So I'm going to say show run access list. So as you can see here, we are saying if it's coming from this network and it's going to this network, go ahead and route it through the tunnel. So let's also look at the NAT rules that we have here. So similarly on the NAT rule, okay, interesting. So we're saying if it's coming from this network, NAT it to this IP, right? That is why on the access list, we now had to reference this IP because this subnet was already NATed because the NAT rule comes first, right? So that's the point I was trying to explain. So we need to also add a second NAT rule in this case that says if the traffic is coming from this subnet, still go ahead and NAT it to this IP, right? And then the destination should remain unchanged. Well, of course, this is not the destination. The destination is this subnet. So I'm just going to grab everything. So up to this point, it's still going to remain the same, right? And then the destination in this case will be the Frankfurt DC. So, right? We're going to say don't respond to proxy app. And can you use route lookup? No. So error route lookup is only allowed for static identity. I'm not really sure what this is saying. Route lookup is only allowed for static identities. So I think what it's saying is if it was a NAT exempt, right? What we're doing here is not really NAT exempt, right? Here, because we are NATing this to this, right? Here is a NAT exempt we are doing here. This is identity NAT, right? But here, I don't think this is not identity NAT. So if you're trying to say, do a route lookup for it, I think that's why we're seeing this error. But I will also check it out after the video. Let me copy it out and keep it somewhere. Let's see. Yeah. Okay. So so we've fixed the access list and we have also fixed the NAT rows. So show run NATs. No, it's completed. I think the command was rejected because we added the route lookup. All right. So let's say show run NATs. Yeah. So that's what we have, right? So we have the NAT rule and then we also have the show run access list. We have the access list. All right, we're going to save on the frag DC. We can also save, right? So now this router this firewall knows that, oh, for traffic destined for the frag DC, it should route it through the tunnel, and vice versa on the frag DC. So now let's go to the interesting part of this video, which is where we actually implement the hairpining, right, or U-turning of traffic. So let me grab the terminal. So now on the London DC, we also need to modify the NAT rules, right? Because so we also need to modify both the access list and the NAT rule, right? So if I say show run NAT, so show run access list as well. So the access list, we have two access lists here, of course. One goes to this goes to, you see, we are referencing the NATed IP for New York DC. So this rule applies for the from the New York City DC, while this rule applies to the other end, which is the Frankfurt DC. I think this is a better description. You can, of course, change the descriptions as well. This is London DC to Frag DC, which makes it easy to understand what the access list is doing. So what we need to do here is, now for traffic that is going to the Frag DC, right? So from the London DC, the traffic that is going to Frag DC, so if it's coming from New York City DC, it hits this ASA and is going to the Frag DC, we also need to, there has to be a match, right? To say permit it, right? Permit and route it through the tunnel. So what we need to do is we need to add to this very access list without changing the name, right? In this case, the source was the London DC local subnet, right? Local network. But now the local subnet has to change to New York City, because if the traffic comes here, we are saying route it. So we are saying if it comes from the New York City DC, then permit it to go to the Frankfurt DC, right? So we have to say permit object this, right? Going to where now? Just going to this place. Going to object. I don't think you need to specify the object. I think it automatically adds it. Does it? It seems we have to. Let's see. Object. What is wrong? Show run. Let's check what is wrong. Permit IP permit. Okay, so let's just do it this way. Permit, if the source is this, you don't need to add the object, I think. Let's see. Okay, objects. Oh, my bad. That was the problem. So we're in the privilege mode. So yes, objects 192. So this is the source to objects yes to this subnet. Okay, so the access list is fixed. So we're saying if it's coming from the London DC to the Frankfurt DC, and if it's also coming from the New York City DC going to Frankfurt DC, ride it through the tunnel, right? Of course, if you do show run crypto map, you see we are matching the access list there, which is this. Okay, so this goes to the Frankfurt DC. So we also need to modify this as well, right? So I'm just going to say, so I'm just going to grab this here and say if it's coming from the New York City DC and it's going to the so this is Frankfurt DC and this is New York DC. Maybe sometimes it's better to use the name, right? So here on access list. Okay, so the access list is modified. We also need to modify the NAT, of course. Here on NAT. So what do we need to do here? Right? Now, look at the NAT we have where we're saying if it's coming from inside to outside, right? So if it's coming from inside to outside, and this is the subnet, and it's going to Frankfurt DC, right? Do NAT exemption, right? Same for this is, I think this is like this is twice NAT, right? Because depending on the destination, we're NATing the IP to something different, right? It's twice NAT, maybe not totally twice NAT, because here we are not actually doing here we are not actually doing we are not NATing the IP, we're just NATing ourselves to ourselves. This is identity NAT, but this is almost similar to twice NAT, because you're saying depending on the destination, NAT it to this IP. So what we now need to do is, for traffic coming from the New York City DC going to the Frankfurt DC, it doesn't get to the inside interface, right? It's outside. That's the whole idea of Hairpining. It's like a U traffic. It comes in and goes out on the same interface. Now, for that to work, you need to enable it on the ASA, right? I think it's let me see, show run pipe include same. We already did it before, so this is very key. This command is very key, right, for you to implement Hairpining, or for you to allow traffic in on an interface and out on the same interface, right? This allows traffic between two interfaces with the same security level, right? So if I have an interface that is 100 in terms of security level, if you enable this, it's going to allow traffic between both of them by default, right? This is to allow traffic on coming through an interface, whether it's a physical interface or a sub interface, and go out and return that traffic back on that interface, right? That's the whole idea. So this need to be enabled, and then we also need to do a NAT exemption for that, right? Is it NAT exemption now? Let's configure it, then we'll tell if there's actually exemption for the NAT, right? So what I need to do is to say NAT, if it's coming from outside to outside, interesting, right? Then I want to put it on the top of the NAT row. So I'm going to say, I'm going to give it a number to put it at the top, and then let's expand this. So we're going to say here that so now let's look at the topology, right? So we're going to say if it's coming from this branch, right? It's coming out, right? It's coming from the outside interface from this branch, and it's what? And it's going to this branch, right? We're going to say don't NAT it, right? So it's actually NAT exemption, right? We're going to say don't NAT it, right? So what we now need to do is so let me say show run objects, like work with objects. So we're going to say NAT outside to outside, right? Put it on the top of the NAT row. It doesn't really have to be, but it's better if it's there. So I'm going to say if it's coming from the New York City subnet, this is the subnet. We know you, This is the subnet. So of course you have to say source static, right? They were saying if it's coming from this subnet, don't NAT it, right? NAT it to itself. Basically, that's what it means. And then if destination is the destination in this case is the New York City DC. NAT source, NAT static, right? NAT this IP to itself. Then we say no proxy app, and then we can say route lookup now. I think route lookup will work in this case because it's an it's identity. There's actually no NATing happening, right? Show run NAT. Yes. Is it broken? Okay, yeah. So this is what will make it to work, right? So we are saying NAT outside to outside. The New York City subnet, it should not NAT it. And also the destination don't NAT. Don't respond to proxy apps, right? And you can do route lookup for that. Okay? If everything works fine, right? Then New York City server should be able to talk to the Frankfurt DC server. Now let's look at it. Let's check it here and see on the New York City server, which is this server. Where is New York City? Right? Let's stop it and then try it again. You have to work. Oh my God. This is nice, right? This is what we call hairpining on the ASA, right? So you can see that right now we are not able to talk to the Frankfurt DC server. From Frankfurt DC server, it's a bit complicated setup, right? So let's go to the Frankfurt DC server. This is our Frankfurt server. Now, remember, this IP is not known by any of the sites, right? So what we now need to do is point to this IP, right? So 10.252 will map to what? 20.252 here. So let's try to ping to 192.168.20.252. Wow, this is nice, right? That is nice. So you see the traffic actually goes from this network, hits the London DC, and then it's routed to the New York City DC. Okay, I'm not sure if we can get anything from the trace route, but let's see. Trace to 192.168.20.252. It should just be maybe one hop. I'm not sure. Let's see. So we might not be able to see anything from the tunnel, right? But at least we know the ping is going through, right? If you're not sure if that's the IP we're actually pinging, what we can do is we can run the continuous ping, and we can go to the New York City server and change the IP. So ifconfig sudo ifconfig internet 0. We want to change the IP now to 10.0.10.10, right? And the net mask is 255.255.255.0, right? You should take it, and then we need to update the default table route. Add default gateway should be 10.0.10.254. Yeah. Need to add sudo. Okay, so the IP has changed to 10.0.10.10, right? We should still be able to ping our gateway, ping to 10.0.10.254. Yes. And now you should see that pings from the Frankfurt server should have stopped because we've changed the IP. So if we ping .10 now, yep, it's working. If you ping the old IP 192.168.20.252, not working, right? Now let's also check that the London can still talk to, yes, as you can see here, so you can still talk to the Frankfurt DC, yes, and it should still be able to talk to The other end is not .10, right? Yes. So let me know what you think. There could be other better implementations for this, for the ASA, right? You can leave it in the comment section what you think. And if you also have questions or certain things you don't understand, you can put it in the comment section. If I see them, I will definitely respond. Now, in the next video, we're going to move on to from site-to-site VPNs and all the, multi-hub VPNs. We're going to talk about remote access VPN, right? The task for the remote access VPN is that this user should be able to access these two servers. This user is work from home, is at home. He needs to be able to access this server. That is very straightforward, right? And then he also needs to be able to access these servers, not by having remote access VPN to this ASAs, but he hits the London DC, and then from the London DC, the traffic is helping again to this remote site, right? You want to see that implementation, then join me in the next video, right? And we can even take it to a different level where we create different remote access tunnels, right? We could say, okay, people from the finance department, this is their servers. They don't have any business with these servers. And then people from network engineering or technical team should be able to access all the servers. And then we can, really implement rule-based access rules to limit what you're able to access once you come into the remote access VPN. It's going to be interesting. You can join me in the next session. If you like this video, please subscribe so that when I have more videos like this, I can definitely share and you'll be first to see them. What we always try to look at is real world scenarios and things that are a little bit complicated. Yeah. So thank you very much, and see you in my next video. Thank you.